If you guys could please take one moment and fill out the attendance form you guys see on screen here. And if you are watching the recording at home and you haven't already, please fill it out there as well. So this is Software Saturdays, Lesson 5, NoSQL Databases. This is our final session. As you can see our curriculum plan right here, we have 2 project days coming up this week, not next week, sorry, the next week and the week after that, which should be the 13th and the 20th of my calendar here. I highly recommend you guys please show up. We won't cover any new material, but we will go through a lot of, working through the problem, talking about the final project, going through the specifications, walking through the examples, getting help, and just kind of getting a good head start. I believe, I'll double check my calendar here, but I want to say the final project will be due on the 27th. So it should give people about 3 to 4 weeks, I think 3 weeks, to work on the project. It should avoid all the midterm projects coming up for most people. However, if you do need an extension, please just let me know, and we will be happy to accommodate and make sure that everyone has a chance to finish this project. Before we get to 27th, yes, Saturday the 27th, it will be basically the week after the second project day, that night. However, if you need more time, like I mentioned, please make sure you let me know. We will be happy to give you extra time, like another couple of days or so to finish it, if you think you're not going to be able to do it by the 27th. Also, we will continue our office hours these next couple of weeks. So we'll have one next week, the week after that, and the week the project is due. So it should be the 11th, the 18th, and the 25th, basically every Thursday, so that you'll have plenty of chances to come in and get help on your project. I highly recommend it. People have been using and taking advantage of those office hours, and it really shows as they kind of learn more throughout the entire semester. So as always, this is the same stuff as I'm going to kind of skip over this because it's the same stuff we have every single week. And one tiny note here is the GitHub has been updated. So lesson 4 is now all the lesson 4 code from last week. I made one tiny change, but it shouldn't be too major. And the master branch now currently has the lesson 5 code, and will be pushed to lesson 5 branch probably next week. I'll talk about this more next week with the project, but we will give you guys some starter code. We will give you guys like a basic JavaScript file, a basic HTML file, and that will be located in the master branch probably by next Wednesday or Tuesday or Thursday. So you don't have to start from scratch. You will have a base plate for the final project. So part 1 is a quick review. We've covered a lot of this stuff these last 2 weeks, or last week with the review last week, so we'll kind of skip a little bit. Lesson 1 was HTML. You have tags and CSS, the idea of groups. Week 2 was JavaScript, the idea of making pages dynamic and interactive. Week 3 was basic VueJS, talking about the idea of the Vue instance and the Vue directives. But can anyone tell me what was the things that we learned about last week in week 4, more VueJS? You can put it in the chat, or you can just say it out loud. We talked about 3 different things. Can anyone tell me what they were? Take a moment, kind of think about it, and we'll go through it in just a minute or so. Yeah, we talked about V4 directives. That's a good one. Vue component, right? There's one more thing we talked about. Can anyone remind me what that last thing? Custom HTML components. That's similar to a Vue component. So it's technically correct, but it's similar to a Vue component that Muhammad mentioned. It had to do with the idea of a V-on. I'll give that hint. And the idea of how you could have V-on be something else. Custom events. Thank you. Right. Good job. So yeah, oh, the wrong slide there. The things we talked about last week were Vue components, which are like reusable HTML tags that act like their own mini Vue instance. So they have their own data, their own methods, their own computed properties, their own templates, etc. The idea of, it's on the slide, but V4, looping through a JavaScript array to create elements based on how many values are in an element, or object actually to that extent. And the idea of custom Vue elements, right? The idea that you can have, the example I gave was a custom, a Vue component with like say 2 or 3 buttons that can raise a different event depending upon what button was clicked. If you want to review any of that, the appropriate slides, again, as always, are on Slack, or the videos for each slide as well are on YouTube. So please go through and review, because you will be using almost all of that for your final project. With that in mind, are there any questions before we move into part 2 today, which is about databases? I do want to warn everybody, however, that this lesson, this first half, is going to be a little bit kind of lecture heavy, because we're going to cover a lot of the background information about databases. So just kind of hang with me. We'll get to the more interesting coding parts towards the end of class today. But seeing no questions that I want immediately on to answer, I'll try to move into part 2, which is databases. So what is a database? Well, simply put, a database is a really easy way to store a lot of data in a very central location. It makes it extremely easy to synchronize this data across multiple users and platforms, and almost every website and every web company in the world is going to have data stored somewhere in a database. For example, some examples here, Amazon has going to guaranteed have multiple databases of different products they offer on their site. YouTube with their databases of videos or even like subscriber counts. And the New York Times, like a newspaper, will have a database of newspaper subscribers, like web access, something like that. So you can see how that can be everywhere. Everyone needs databases. Even us in our current, to-do app, we had to store our to-dos somewhere in a database. So for a long time, and I mean really like decades, the standard, and still is actually to this day, the standard is SQL, or Structured Query Language. It's also pronounced SQL or SQL, depending upon your preferred. I call it SQL, however you want to do it, up to you. It still is and was the standard for database programs. So a lot of companies still to this day use it because it's robust, it's powerful, it's extremely easy to use. And it uses the idea of tables, where a database consists of different tables where different columns represent fields. So the example here is like a users table at some login site would have a column for their name, a column for an email, and a column for a password. In reality, don't ever do this. It's a very bad security practice, but it's an example of how databases would be structured. And for a long time, this is how people did things, right? You could think of it like an Excel workbook, like a spreadsheet, right? Where you have each kind of like table being rows and columns, where each column is a different data type and each row is a different entry into the database. However, not all data in the actual web can be structured in this very rigid table kind of sense. Plus, SQL can be a little slow for web applications and harder to distribute. What does it really mean? Well, SQL needs to be stored in like a central location. And it's really hard to have like multiple SQL databases around the world because, for example, what reason you want that is, for example, a user in America would want to access an American version of your database, whereas a user in Europe will probably want to access a European version because it'll be faster to load. And with SQL, it can be a little bit harder to make that work, but still very doable. To not have that be a problem, people created the idea of NoSQL, which stands for kind of not SQL or not SQL. And these don't have a set standard of storing data like the table format of SQL databases. They're very much depends upon the actual piece of software you're using. As a result, this means that it's extremely fast. It's very easy to scale it up. So you can have multiple clusters of databases across the world. It's incredibly easy to develop with, right? Because the software tools are so modern and they're so easy to kind of work with. And as a result, it's also a lot faster because it integrates very well with different modern software tools like JavaScript. I'm not sure if that's on this slide or the next slide. No. So different kind of implementations that you guys might see in those SQL databases include things like a key value, a key object pairs, where the data is structured like a JSON object, where you're going to have some kind of key, and then the data associated with that key at that value, or a key, and then some other kind of nested layer of data within that layer. And we'll kind of show all of these in our NoSQL examples. Other one is the idea of collections. So you'll have maybe this one collection for this one user, this one collection for the second user, and each collection has what we call documents, which are kind of like just a document, a list of data in like a very structured order within some kind of collection. So you can see there's a lot of different options. There's so many, and every kind of software has their own preferred implementation. And we're going to go through only one of them in this class that, it's probably one of the easier ones to get set up and used. That one is called Firebase. So Google, the company, has a developing software called Firebase, and they have a NoSQL database. We have two of them, but the one we're going to use is called Real-Time Database. Real-time database is really easy to use and set up, which makes it perfect for developers like us who don't want to spend time, hosting servers or reinstalling expensive software. It's a simple 5-6 clicks and you're good to go. So part 3 is all about Firebase. What is Firebase? So like I said, Firebase is a Google development system for prototyping small applications. It's perfect for developers like us, like I mentioned, because there's so many features and it's all free. If you don't go above certain usage caps, which you probably won't hit anytime with a kind of small project, it is free for you to use. And Firebase has a lot of useful features and services. We are only going to cover one, the real-time database, but if you ever want to expand the way your site works or even host it somewhere, look at Firebase's offerings. They'll be extremely, extremely cheap, actually free for most users, and they're relatively easy to use compared to some other, like say AWS or like Azure. So real-time database stores things using a JSON structure. So recall back, JSON stands for JavaScript Object Notation. And it's kind of like a standard on the web for storing data. The idea behind it is like it follows regular JavaScript conventions. So key value pairs, where each key has some data associated with it or has some nested object within that key. And again, we'll show examples of both of these with our data. This means that it's extremely easy to use JavaScript, since JSON literally is a native JavaScript type, meaning JavaScript can very easily handle the JSON data, interpret it, modify all that without having to do any kind of conversions. In comparison, some other languages need to use some fancy tricks and tips and tools to make it work, whereas for us, it's as simple as using or just import the data from Firebase and just use our regular JavaScript methods for everything to work like we want it to. Before we go any further, are there questions at all about real-time database or about NoSQL or databases in general that people want to get out of the way right now? All right, I'm not seeing any, which is perfectly fine. Oh, sorry. AJ says, using JSON with Java is a pain. Yes, a lot of languages like Java, C, C++ don't have support for JSON at all, really. And what they have to do is convert it using a whole bunch of tricky methods called hash maps mostly to kind of get a JSON-like structure done. But because JSON is a text version of what JavaScript naturally has, it's super easy to use in comparison. So with that in mind, we're going to jump into what I'm going to call demo program 1/checkpoint 1. And that's going to be setting up Firebase and real-time database with everyone here together. So if you guys, I did something in my email and on the Slack message, make sure you guys have a valid Google account or make one if you need to just for today, because Firebase does require one to work properly. Actually, these numbers are wrong, but if you can't follow along, slides 22 through 30 are going to have the same information in like a picture snapshot form, and the GitHub in demo 1 also has this instruction in a text-based format. So if you miss a step at all, you can go back and get all the help you might need. So with that in mind, I'm going to walk through it. If you want to have this open, like minimize and kind of listen to what I'm saying, or have it like follow along, whatever you want to do it. Try to get Firebase set up along with me so we can jump straight into the coding part of it after this. So first things first, the first thing we have to do is go to the Firebase website. You can go to either firebase.google.com or just firebase.com. It's the same URL. And you'll see this website, the kind of landing page here with all of their products and offerings and stuff like that. Once you're at this URL, we're going to go into the upper right corner to the Go to Console button, which should be next to your profile picture if you are signed into Google. If you are not signed into Google, after this button, you will have to sign in. So please have a Google account ready. Once you are in the Firebase console, you may have to accept a couple of terms and conditions for the first time, but you'll see a page similar to this. If you have ever worked with Firebase before, you will see your projects right here. I have not, so I have mine, but if you don't, yours will probably be a single blank box with the words add project. Does everyone kind of see or has been able to get to this landing page with the add project or list of projects they may have already had? You can just say, yes in the chat, tell me out loud, use a thumbs up in the reaction menu. Okay, I see a yes. So I'm going to say that most people probably have got here. Once you're at this landing page, click on the add project button. Once you're here, it's pretty simple. Just kind of give your project a name. I'm going to call mine Vue Lesson 5 because you can have whatever you want. Again, not super important. I want to call it just Vue Lesson 5 so I know that this whole setup is for the 5th lesson of my Vue project. Once you have that, hit the big continue button. Pretty easy. I recommend turning off Google Analytics. However, it's not super relevant which way you do it. I just don't like giving Google more data than they already need. So then after you either choose to select or deselect Google Analytics, press the Create Project button. That will kind of, already exists, my bad. I have to redo it because I already have one with that same project name. VueJS lesson 5. I think I had my testing one for this lesson already set up, so I can't use the same name again. But same process, it's a different name this time, create project. Give it a few seconds. It probably takes about 30 seconds to create your instance and all that stuff, so let it be. In the meantime, are there any problems so far with getting the Firebase project set up that people have? Are people able to follow along? Okay, I don't see any problems. That's a good sign. So once it loads, so about 10 seconds, you guys can see, hit continue to kind of move forward into your project. And you will automatically be thrown into the kind of landing page for your project. Well, once you do that, it's actually not too complicated to get real-time database set up. To do so, on the left menu here, you'll see all the possible things that Google Firebase offers to developers like us. And you can see there's this build stuff, like actual tools we can use, release and monitor, so stuff that we can use for actual testing and analytics, and then actual analytics on the bottom here. And as long as you stay within low usages, your bottom here, your plan should stay Spark and remain free at $0 per month. You can look at the pricings, but I highly doubt any of us are going to be needing anything more than the free stuff for at least a little bit. So once you have your project created, go to the real-time database set menu on the left here, the third option here in the build category, and press the top, the center screen here, create database. And you're going to probably just choose the default US Central one. Don't choose a European one because you want to keep your data close by. And click on the next button. For security rules, now I have a slide all about this in my presentation, but you're gonna, because you're testing database out for the first time, choose start in test mode. I'll give you a little bit of a warning pop-up here. Make sure that you do not publish this database or this website you're going to use with the database to the web. Because test mode, what it allows you to do is anyone to read or write data to the database for 30 days, meaning unlimited, uncontrolled access. There's no kind of authentication, no sanitation, nothing. So it can be extremely easy for people to come in, steal, and corrupt, modify, or do other nefarious things with their data. I highly recommend you just keep it in test mode for testing, as the name suggests. But once you do so, if you want to actually ever deploy this to the web, learn about Firebase rules and how to use them properly to make your data secure. But for this lesson, we're going to start in test mode. So then enable, once you have test mode selected on the radio box here. Again, give it a few seconds to properly load. Once you have that, your database is technically created. So you are good to go. Now, I'm going to give you guys so this is actually what your database looks like. It's going to be blank when you begin off, obviously. But we at Software Saturdays are going to give you guys some example data you can use to just kind of test with that we know everyone's going to have. So everyone is going to be able to do the same kind of demos and projects using Firebase. But before we do that, are there any questions or problems with getting real-time database set up? Okay, perfect. So one thing I do want to note here is I pull up the GitHub for the master branch has this file in the very beginning called data.json. And data.json is going to be the data that we're going to give everyone to actually add to Firebase for their test data. It's a kind of a list of Software Saturdays sessions and information, so nothing fancy, but recommend you copy this into like a file somewhere or paste or download it if you don't clone it if you want, and have it saved somewhere on your computer because you're going to have to import it into Firebase. To import data into Firebase, once you're on the real-time database menu, click on the little 3 dots in the corner by your database name. So right here, click on it, and click on export or import. We want to import because we're uploading data. Import JSON. We're going to import it. And it's going to tell you, all right, it's going to be overwritten, no problem there. We know that because nothing is stored there. And it's going to ask you for your file. So click browse and navigate to wherever you store your file. I know mine is in this folder here, data.json. So I'm going to click on it and upload data.json to this location. Once you have it imported right here, click on the import button, right, to finalize our import and wait for it to load. And if we hit expand to show the data, as you can see, all the data is now officially loaded into our database. And here's what I was mentioning. We're talking about the idea that Firebase stores data in a JSON tree or JSON object. We have this root, this root kind of name, this blank regular object at the very top. This name of your project here, and underneath it we have 4 different keys, right? Yeah, fall 2018, fall 2020, spring 2020, and spring 2021. If you open any one of the keys, you'll see that each key is actually each key's value or data is stored there is actually a sub key with more fields. So for example, open up the spring 2021 here because that's the current semester. The spring 2021 key has actually the object with 4 more keys. It has the final key with the value to do app, the location key, the program key, and the school key. And if you look at the actual JSON file in the GitHub, right there, you'll see it looks very similar to that, right? The spring 2020 is a key, and the actual value stored there is another nested object with 4 more keys: final, location, program, and school. And we will use this data for testing. So all 4 of these are just kind of have sub-objects, nested objects as their data, with all the different information about all of the past 4 semesters of Software Saturdays. Once you have that, our database is ready to go. We are, finished importing. We have a test application. We are doing good. Small problem. Because Firebase is meant to be a secure application, by default, it actually disallows anyone from using your database without the proper configuration. So how do we create the proper configuration? Very simple. Before we do that, I should probably ask, is anyone having any problems importing their JSON into the database? Have people been able to import it properly and see a similar structure that they see on my screen? Okay, see a yes from Sam, yes from Elisha, Alan. Thank you, everyone. Yes, so it looks like it's going well. So once we have database set up like we have on my screen here, on the left pane, go up to Product Overview, then the Settings gear, and go to Project Settings. Once you have that, you'll be at the actual overall settings page for your project. To actually use your project on the web, scroll down to Your Apps. Now, the name apps is a little bit kind of misleading because when we think of app, we think of like mobile apps. But in reality, apps just means any kind of application this name is short for, including web-based applications. So you can see there's three kind of, I think it's four technically speaking, but these three blue icons that represent different kinds of apps that we can use. So naturally, we're going to choose a website. The website is it looks like an HTML tag, like a blank closing HTML tag, a little bracket and a slash in the middle there. So click on that. And it'll say in the very top, add Firebase to your web app. Now we have to give our app a name. So you can name it whatever you want. I'm going to call mine Lesson 5 Demo. Again, this nickname is not important. All that is used for is that you, the actual programmer and developer, knows which configuration goes with which kind of file. Don't choose Firebase hosting. That's not important for now. Once you have that, click on Register App. And once you register the app, it's going to give you a little second, and it's going to give you this nice big text box. I recommend you copy and paste this into like a separate document you store somewhere because you will have to reference this in the future. Now, if you guys look at it, it's technically HTML, right? You have an HTML script tag and the second script tag with like some inline JavaScript. You can copy all of it if you guys want to, or only copy this var Firebase config type. Again, up to you. The demos that we have on GitHub will only require you to copy and paste this stuff inside of the config. So all of these kind of lines that begin with API key and end with app ID. But you can choose whatever copy paste you want to do. I'm only going to copy this because I don't need anything else. Copy paste that. And once we have that, we can go back to our console. And we now have finalized our Firebase setup. Was everyone able to get their Firebase set up? That includes getting the keys, the data, everything. All right, I'm going to say people have.
What tab are you on right there? Sorry, I'm not quite sure how to get to that tab that you're on.
Yeah, no problem. So to get to this tab, you're going to click on the settings gear in the left window there.
Mm-hmm.
Go to the project settings kind of like option, and then scroll down.
Okay, thank you.
Yep, and you should see the your app section. You will choose like the HTML, like the tag looking symbol to add a new app to your Firebase application or Firebase project. Jonathan asks, do we save the Firebase as an HTML file? Again, up to you. So as you guys can see this kind of like mess here, the same way you guys saw on screen, it is HTML. It technically is HTML. This part here, between this top, it says your web apps Firebase config down to Firebase initialized app is regular old JavaScript. I personally know that the demos that I have created only need you to copy and paste the lines within the Firebase config object. But if you want to make sure, you can just copy the entire block and get copy paste as you need into the different parts of the application. But again, I'm only going to copy this because I know I only need that. However you want to copy is up to you as the end user. As a developer, sorry, the developer. Are there any other questions that people had? Not sure where to go, where I am, stuff like that. And again, all of these setup instructions are on the slides as well, on slides 22 to 30, as well as on GitHub in the demo 1 folder, the document with the same instructions on there. So if you want to go back, there are plenty of places to do so, or even just ask a mentor in a breakout room. That also works. At this time, we're going to jump back into our presentation. And if you guys still have problems with Firebase, please ask a mentor in the chat, or ask a mentor in the breakout room, or on Slack, or kind of try it yourself. All are good options. With that in mind, we'll skip ahead to slide 31. And again, this is another reminder because I want to drill it into people's heads. Your database is in test mode. Anyone, and I read anyone, can write or read to it for 30 days. As a result, do not publish this website like this or the database like this to the web. If you intend to use Firebase or use your final project on the web afterwards, like see a portfolio, look into Firebase rules. Make sure you know how to control access to data in your database. If you do not, you are bound to have a big problem where people can come in, corrupt, modify, steal, or delete data that you want to be stored. Now you can see, very big here because it's extremely important. It's a very common mistake to do so as well. Do not do this. All right, part 4 is JavaScript time. So what JavaScript means, adding Firebase and NoSQL to JavaScript. So this is a simple random comment here I have here for note only. If you want to add Firebase to HTML, you would kind of paste that copied config, the whole HTML block at the end of a body tag. And then under the to-do comment, paste this script line. Basically what happens is Firebase needs to load in some kind of called SDKs or software development kits that help it know like what APIs to use, how to actually read the database. And all of that is stored in different files. The first one you need is the firebase.js file, because that kind of loads the core libraries. And then you load in the database file for the actual database queries. Our templates will do it for you. All you would have to do is copy paste the config I kind of copied on screen there that you guys saw into your JavaScript, and the rest of it will be automatically pre-filled out for you. But it is worth this in case you need to do it yourself. Here's how to do it. So to actually access your database, you can use a function, firebase.database. As the name suggests, this creates a database and stores it right as like a variable from Firebase, and you can access it by using the Firebase, where Firebase is defined automatically for you, .database, the function. You can, I would recommend you store this as a variable somewhere. So you can use this in JavaScript elsewhere for ease. For example, you can say like let database equal firebase.database. That's actually how I do it in my code. You can choose a different name if you want to, but it makes it easier since you can only have to type database, not firebase.database every single time. But like I said, our demo programs will do it for you. So don't worry about that too much. Next, how do we use Firebase in JavaScript? Well, here's a basic principle you would use. First thing you do is you need to know what data to actually modify, add, copy, delete, etc. To do so, you have to actually create a reference to the data. I don't want to call them references like C++, like pointer references, because they're really not. It's more like a path through the JSON tree to the data. Firebase provides a script to get these references automatically and create them in the proper format. That format is the database variable name, and asterisk there, whatever you call yours, .ref or ref function, and that will return a reference to the data you want to either add, modify, delete, or read. And then the parameter is just a string path to the data. So what do you mean by string path? Well, it's structured kind of like a URL, actually. So each kind of key you want to read from is a slash, and then the name of the key, then a slash. And then if you want to go within a subkey, you would do /name, /subkey name, /, and that'll be there at that subkey. Here's an example. If you want to read a reference, if you want to look at a reference to the Spring 2021 object, we can use ref and then quotes / Spring 2021. And that'll be a reference to the Spring 2021 sub-object, the nested object. However, if you wanted to access a key, right, within that one, like say I think it's a final key, we can actually do / Spring 2021 and then / final, where / final is a key within the Spring 2021 like parent object. So if we kind of think back to how data is structured in the JSON tree, the Spring 2021 is the data value that's associated with that key is a nested object. And that object has 4 keys, one of which is final. And then this path here represents that final data stored within the Spring 2021 area. If you were to change that to Spring 2020 / final, it would instead be a reference to the Spring 2020's final, which was, I think, a YouTube clone, if I remember correctly. Whereas this was going to point you to To-Do app. Are there any kind of questions about references? You'll get a good example of them with a demo program. All right, cool. Now we talk about how to actually kind of change through actually kind of go through and modify, update, delete, read / data. To change data or modify data, once you have a reference, you can use one of these 3 references, these 3 functions here, to actually do different things to your data. You can use .set, .update, and .remove. So .set is a function that takes one parameter, data, and that adds that data value, whether it be a string or another object or whatever you may have it set to, at the reference that you gave it. So if the full command here, for example, was database.ref spring 2021.set, it would, and then we passed it in some data value, it would set the key 2021 equal to whatever data was within that value. Next is a .update. Well, actually, to go back to .set. The name .set is set, but in reality, you can kind of think of it like adding or creating data. Because wherever you set data, all of the old data at that key is deleted, and the data you gave in that as a parameter function is now added to that. So if we were to set data at the 2021 reference, what would happen is all of the old 4 fields we created that we had before would be deleted. And the new data we gave it would be replacing the old one. But what if you just want to modify or update the data, right? Next, you can use the update command. So again, update takes one parameter, data, and what it will do is update the data only, that data only at the reference. So let's again, to go to our example, we say the Spring 2021 reference. If we update the data, the value of final to something else, it will only change the value of final and keep the other keys just the way they were. However, if you choose to use .set, it would delete all of the old data and replace it with the new value of final. So if you want to add data, use .set. If you want to change data, use .update. Does that make sense to everybody? All right, I think it does. Good. The last one is .remove. As the name kind of suggests, .remove just deletes all the data at that reference, as well as the actual reference itself. So if we did, say we chose a reference of Spring 2021, like the old examples did, say .remove, it would actually delete all of the data at the Spring 2021 key, and it would delete the entire key as well. So that key would no longer be in the database at all. And if you guys want to play around with it, please do. And if you do make a mistake you can't come back from, you can always just, re-import the data file and, have your database be back to normal pretty quick. With that in mind, let's jump to reading data. So reading is a little bit more complicated. There actually are a few different options you can use to read data from a real-time database. We're only going to use one. We give you an example of how you lay it out here. And that's because real-time database actually likes the way it's meant to work is it'll have what's called like a callback handler, meaning the data is always synchronized with the database. What that really means is that if another user were to say add or remove or modify some data elsewhere, those changes would be made in the database. And then if we were to use like a regular Firebase approach, would automatically kind of copy from the database and be brought down to your web app. So your web app always has the latest data available. While that's really useful and powerful and extremely, extremely wanted in most cases, it also is a lot harder to implement properly. So we're going to use a little bit of an easier approach where we only read the data one time. And then any time we want to get the new data, we have to reload the whole database. And you can tell because we're using the .once. .once just reads the data one time. So this is a very long function. We're not going to go through all of it. Just all that you have to know is the reference part here has to be replaced with the reference that you are, referencing the data you want to reference. And whatever you do with the data has to happen after the top line. Let data equals snap.file. If you want to dig into it, I have a slide about that. You can look into this a little bit, but we will not in this class talk about what all these little functions do. However, it's recommended that if you want to learn more about this, you definitely do. Are there any questions about reading, writing, deleting, etc. data from a Firebase database using JavaScript? Okay, I'm not seeing any, which is a good thing. With that in mind, I've been talking for quite some time now. We are going to hop into demo program number 2. So demos on GitHub, like I mentioned earlier. Let's bring it up. So as a quick refresher, demo 1 is just a README with the instructions on how to create Firebase and real-time database, and then like how to do it in text-based format. Knock it out. Demo 2 is the fun stuff. So HTML, JavaScript, and CSS. This is a pretty basic CSS. We're not going to look into it too much. Our JavaScript. Now, this is actually non-using Vue. I'm just using plain old JavaScript here, and you'll see why, because it's a little bit easier to kind of interpret the first time. But then we'll talk about adding Vue in a little bit. So if you guys see here, the demo 2 file already actually has the Firebase functions loaded in automatically for everybody. So you can see we already have copy pasted the Firebase commands you're going to need right there. And so as long as you kind of follow this format, you will be good to go. Next is the demo2.js. So this is a function that actually has, it's a file that has 3 different kind of components to it. Reading data. Am I cutting out badly? Okay, like I was mentioning, this top part here is the Firebase config. So within this kind of line, what you're going to want to do is actually paste the Firebase configuration you copied in from the Firebase setup. So I'm going to paste mine right here. And you'll see it's going to be like, the key, the domain, all of that. You don't have to worry about that. It is kind of more for Firebase to know what it has to do on its side. Nothing you don't worry about. These next 2 lines are, like I mentioned, on inside of the PowerPoint. This one here kind of just tells Firebase to like load properly using your configuration settings, so your key, stuff like that. And this next line tells it to actually load in the database. So like I said, I recommend, just because it's easiest for everyone, if you just do it this way for yourself, essentially, do a Firebase.database and then store that in a database variable called, I call mine let database. Yours can be like whatever you really want. This next section is how we read data from a database. Now, the way I have it is a little bit kind of messy. I don't know if I recommend doing it this way. Can you pop this over here so I can just have it open the side? I wouldn't probably do it this way in your final project. It's a bit messy, but essentially what it does is it reads the data. So again, here's that kind of line, database.ref. So ref, if your ref is like a plain slash, that just means load the data from like the root data node. So basically load the entire database from your program. Then dot once to load it only one time, and then value, because again, we want to load the value only once. And then ignore this part for right now. And all you have to know is that snap.val is the result of the database. So I have a comment here. This is a nested for loop. What it really does, all it actually ever does, is it goes to the database and actually prints out the result of like the parent key and then each sub key. If you want to look at how it works, it's a little bit messy, but it does technically work. It's using a basic, for loop, so for key in the object returned by snap.val, it prints the key out. And then for each sub key, because again, because of the way our data is structured, snap.val is a object. Sub keys, because it'll have multiple sub keys within each object stored within snap.val. We just load that in and print out the screen. You are not expected to know how to read or write this. Just know that what it will do is print out the results of the database query into the screen, the console, because the console.log. And then have a divider line to kind of show each separate kind of, database entry. This next function using set will create. So again, set is more like a create than it is set. It will create the added reference. So referencing added. And if you remember back to our database, added doesn't exist. That's because you can make a reference to data that doesn't exist. What will happen is if you try to update, delete it, or read it, it'll cause an error. But if you try to set it, then it'll just create it for you. So because added doesn't exist, all we can do is set it. So we set it equal to this object, which is key value, and other key equals other value. And so I'll show you what happens in the actual database as we load it. Next, we have using update. Again, update, because added now it exists, we can use the other two functions like update and remove on it. So added, they'll update, we're at the path added, we're updating other key, which was at other value, to the new value of other value to a new value of new value. And then finally, using delete, we're just deleting the reference, straight up just remove it. So we will no longer have added in our database. Does that make sense so far? Any questions about this demo so far? Could you just remove key or other key? Yeah, if you change this to added, say, /key, what it will do is actually remove that only key. If you want to remove both, you would just remove the whole added, value. And if you want to remove just other key, you could just say added /other key. Oh, sorry, other key, my bad. Again, it's a bit tricky to think about how databases, especially Firebase, kind of store this data, but it's a JSON tree. So you can really delete whatever you want as long as you know the proper path to it. Does that kind of answer your question? Good. And yeah, the reason why while remove will actually remove the key itself too is because if you think about it, you can't have a key with no data. It's kind of like makes no sense. And so if you are removing the data at that key, it makes sense you also have to remove the key itself, since you can no longer just have an empty key without any data to with it. All right, let's load up this function, load it up here. So I'm gonna, oh, sorry. So Elisha asks, so update is like appending new data, while set is like a forced write. Actually, it's a pretty good example. Thank you. Yeah. So update, yeah, like I said, is just updating or adding on data to the reference. And set is a forced write, meaning it'll delete all the old data and overwrite it with the new data. That is correct. Can you set the key's value as null? I've actually never tried using null, but I know an empty string would work as well. And you could try that. I can try it for you right now if you want, but I've never tried null before. I'm not sure if it's going to work because it has to be valid JavaScript object notation. And I'm not sure if null is valid JSON or not. It could be though, I'm not sure. Oh, okay. Oh, Firebase, whoops. Wrong, the wrong thing here. Okay, so here is the demo kind of your web page. Pretty basic, but I'm also going to load up the Firebase console in the meantime, because I think that we will definitely be using it here. Go to database. So here is the data. Now I'm going to open up my browser console, F12, again on most browsers. And if we pull up the browser console, you can see that our read command read all the data from the database. So it has the data, the key, then all the subkeys and their values with a divider line in between each one. Now, if you want to actually modify, like add, update, or remove data at each reference, we have to use one of the functions that we defined. So to actually show how that works, right, and how it actually makes a change in real time, I'm going to have the console tab open up in this window and the Firebase open up in this window. So if I have them really carefully, you should be able to, nope, that's the wrong button. You should be able to see both at the exact same time. Sort of. We'll look on the bottom here. Now, if I show you this, watch what happens to this key. So first we're going to set data, meaning we're going to add it to our database. So that was define the function using set. No parameters. And if you run the code, watch the database. The second I run it, it adds in the new key just like you want it to, right? So add it. And the key has a value, and other key has other value. And the changing, as you guys saw, was instantaneous, more or less, meaning this database will always have an up-to-date copy of the data. Next, we'll try to update the data. So we'll change this to using update. And remember, update should modify the value of other key to, I think it's new value, I want to say. So run our code. And you can see it instantaneously updates other key to new value. And finally, using delete, we're going to remove added value altogether from the database, just like that. And it's gone. So if you catch the color on screen flashing, that's because of a legend. If you actually show the legend here, the yellow color means that the data has been changed. Green means added, black means deleted, and blue means moved. I haven't ever actually seen the blue show up before. I've only ever seen yellow, green, and red. But you can see, you might actually see them. I'm not 100% sure. But that kind of gives a good example of in real time how the data changes. So Sam, to answer your question exactly, what I'm going to actually do is try this. We're going to say, actually, I'm going to say using set. I want to recreate my added field. We're going to run this. We're going to say database.ref. So we're going to say refer to the added key and then just a regular key. And we're going to delete that. Oh, is it delete? Yeah, delete. Whoops, is that the wrong? Why did it not work? Hold on a second, this is very confusing. My bad, sorry, this is a new demo, which remove, my bad. I used the wrong function there. Gotta be careful about that, remove. And you can see, because we only gave it the key value, we can now only remove the value of key. And then watch this. If we, just to kind of give you some more examples of set versus update, if we run a set command, or update command using update, it'll now only modify the other key value, right? So we change the value of other key, but now if we run the set command again, using set, it'll overwrite the value of other key with other value, the value we had in set. And so that's because set, again, deletes all of the data and then adds new data. So if I want to up it to null, I saw the question that Sam asked a little while ago. So database.ref added, and we'll say .update because we want to add data to the database, not like add a new field. We'll give it a field of test and a value of null. This may not work. Let's find out. That does not. Oh, I can't spell. Whoops, never mind. What does it say the problem is? It tried, but it looks like it was not able to make the change because null is not a valid data key. However, I think a blank one should be, so we can probably just use a blank, like a blank string, and that should update properly. It's 2 strings. Yep, and as you guys can see there, it added the test with the string value of null, but regular old null does not work because that is not valid JavaScript. Are there any questions with this demo program? Yeah, so an empty string, if you guys can see in this test, that one worked. Using a plain null, like a null, does not work because null is not a valid JavaScript object notation format. But a plain string saying null does work, or like an empty string would work. Yeah. So, can I get a history? Yes. So database.ref added, and we'll say .update. We'll say test, then a blank string. That does work, as you guys can see. Because again, a blank string is still valid JavaScript, but null is not valid JavaScript notation. It may be valid JavaScript, but it's not valid in an object. So that would work. And then it's because, is key without quotes interpreted as a string type? So here's the tricky part. Keys are by default not any kind of data value. They just kind of exist. So in regular JavaScript, string object keys do not need quotes because they're not really string. They're just kind of like this. Again, they kind of exist as a property of the object. The tricky part comes in when you turn that JavaScript object into a file, or like we want to what's called serialize it into a format that other languages can use. You then have to put strings around it. So the way I would treat it is, because of the way that JavaScript is a little finicky with the data types, if you see something like this where it's test, right? Treat that as a string always. And you'll see that when you turn it into a file, like if we turn this database into a file, added, all that stuff, the keys are also strings themselves. However, and here's the tricky part, the number 0, we'll say, can be treated like a number. Oh, am I robot again? Sorry about that. Yeah, my network is not having a good time. Yeah, I'll check, but I think the recording might not have that problem. So hopefully you can listen, you can watch that if you want, and that should fix it. Okay. So yeah, so here's the tricky part. The number 0 will be treated, if it's the number 0 and the number 1, that would be treated like numbers. So it would be the number 0 and the number 1. But then the weird part about JavaScript is you could just give the number 1, then the 1 becomes a string, not a number. So my rule of thumb is avoid using numbers as key values, or as key names, and to treat every key name as a string. And if you do those two things, then you will not have any, if many, bugs in your code. But if you do use numbers, be aware that JavaScript and Firebase may choose to treat the number as either a number or a string, depending upon if other numbers exist and what values they may have. So it's a mess. I just, again, try to avoid that if you can. Is that kind of like, it's a very long answer to your question. I'm sorry, Elijah. But does that kind of give you some answer? Okay, so yeah, it's a very long and very kind of confusing explanation, but I hope that gave you a good overview. So with that in mind though, were there any other questions about this demo number 2, which is mainly about how to read, write, update the data from a NoSQL database on Firebase? What is the syntax to move data? You know, I have no idea. I have yet to figure it out. But if you want to give it a try, Firebase docs, I'll put a link in the Slack, is amazing. So look at the API, iOS one, the API for web, and you can see there's literally all you'd ever want to know for database here is going to be somewhere in the API. So I'll just link the actual API to everyone. It's a little bit long-winded, so it's also very technical in nature. Firebase documentation. But if you do want to move data, that would be the best place to figure it out. But I can say from personal experience, I have really never had a reason to move data before. But I'm sure that you could come up with reasons to do so. Any other questions? Perfect. Okay. I don't see any at the moment, so we're going to jump quickly back to here, back to our slides. We only have a little bit more left. Elisha asks, can you read data in a way that can be written directly? Can you kind of clarify that? What do you mean by in a way that can be written directly?
I mean, like the whatever object that you read back, that you can sort of write it in a symmetric way that you read it, like so that you could maybe create a sort of copying or moving function.
Oh, okay. I think I see what you're saying. I'm going to try to answer it. It could be the wrong question though, so please fix me if it isn't. So from what I think you're trying to get at, what you can do is, so this, where'd it go? This snap.val, aka this, like the return for this read function, is a regular plain old JavaScript object. So you could, in reality, just turn around and pass snap.val to like a set or like an update function, and it will be in the proper format to write it to something else. Is that kind of?
Okay, yeah, that was exactly what I was looking for. Thanks.
Yeah, okay. Yeah, because again, remember, Firebase stores data, especially in the real-time database, as a JSON in JSON format. And JavaScript is, again, natively designed to work with JSON. So the data returned, the values returned by it work next to perfectly without any kind of conversion required with other JavaScript code. Okay, is there anyone else? Good questions, by the way, guys. All right, I'm not seeing any, that's fine. Then here's advanced reading, like I mentioned like a little bit before. If you feel comfortable with this as plain, like these simple operations we did, and you want to make your programs better, I would look into something called promises, because each Firebase operation in reality is a promise to complete it in the future. And there is a proper way to handle these promises in JavaScript. You might have actually seen a promise in my read function if you know what promises are, because that's what it is, really. AG says, ew, promises. I would say they're tricky if you're not used to them. If it comes from a different language that hasn't had the idea of like asynchronous or promises, they're definitely very confusing the first time. But once you get the idea of how to use them, they're really not that bad. And if you want to practice how to use them, come to office hours, hit me up on Slack. I'll be more than happy to help you walk it through. All right, so here's a little bit. This is not about data. This is more about database. This is more about data in general here, in web development in general. But proper web development principles state that any kind of like fully featured web app, which is your final project, must have a set of principles that they must implement for user interactions. These actions are collectively called CRUD, and your project must implement all of these actions, or at least as many as you guys can get. All of them should be doable because you've learned how to do all of them, actually. And you can just kind of copy and modify code from the demo to fit these actions. So what is CRUD? CRUD is these 4 basic actions that really any user should be able to do. C is for create, which means create and store data. R for read or read available data. U for update existing data. And D for delete existing data. You guys can see pretty clearly why a web app might, or even any kind of app, might want to be able to do all 4 of these. The user definitely needs to be able to read something, creating it, important, updating it, a little bit less so, but still, if for like a to-do app, important. And then finally delete, also important. And so CRUD, these kind of CRUD principles or CRUD actions or CRUD apps, as they're kind of more broadly called, are kind of the foundation of web development. And if you think about it, create is like a set command, read is like the read, kind of like what the read function, the read, how to do a read. Update is like an update, and delete is like remove. So you already know how to do all of these. It is a matter of figuring out exactly how to do it. And then finally, this is more, again, about a little bit about Vue and integrating it with Vue. It is best to load the data with Vue only after the page fully loads. And guys, I know I've been talking for quite a while here. I'm sorry, it's a pretty lecture heavy day today. We only have, I think, 2 more slides, and then it's into a checkpoint for everyone to work on for the remainder of class today. So the reason why you only want to load data with Vue is that the data is now only there for the user when the user wants it. Oh, sorry. If you load it before the page loads and the page, say, has an error, you have now made an unnecessary database query that could cost the user, like database time, it costs you money, it's not very good. And if you load it too late, then the user won't have the data when they need it, meaning there's a delay and the user experience is less enjoyable for the end user. So it is best to try to only load stuff when the page fully finishes loading. Well, how do we do that? Vue, fun fact, has this very special created function that will only run when it is fully loaded. It's sort of like a normal function in the methods part of the Vue instance, but this function is only run once on a page load. As a result, it's extremely important and actually very good practice to put the database read within this function, not somewhere else in your code. So what do I mean by that? So here's kind of like the basic Vue instance we learned about, right? This past 3 weeks, right? In the EL data methods and computed. Well, there's a separate one here, created, I have it highlighted here, created, then it's a function. So either regular function header, and then the function body would be between these little 3 dots. And you would put your database load and whatever else you do with it, the database read, within that function. And it will only be run one time and only be run once the page fully loads, which makes it very useful for a web app. Now, I know there's a lot of info this session. I'm sorry about that. But were there any kind of questions people had about CRUD, web apps, Firebase, databases, Vue, anything like that? All right, I'm not seeing any. That's okay. With that in mind, we're going to hop into checkpoint 2. But before we do that, just thank you everyone for coming. Review hours, blah, 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 feedback form. Please fill this out. I know that I want to see how people feel this session, because I know this was not exactly a very interactive one, unfortunately. So again, really sorry about that. We just had a lot to get to. So it is time for checkpoint number 2. So checkpoint 2 is using Firebase, display the contents of the example data that we gave you guys using a Vue component, or whatever you want to do it. You can maybe, if you're feeling up to it, again, this is more optional. This is the required part, or not the required, but the heavily do this first part. And if you feel confident with this, then try this part, which is add some buttons and text boxes to add or remove data from the database. My example only implements this first half here. The second half should be an extension of what we've learned about with the methods and on-click functions, and shouldn't be too difficult to include. And as a very, very big hint, this kind of format here is almost exactly what you will have to do for your final project. So if you kind of figure out how to do it now, you are in a good shape to kind of modify this for the final project. I have given you guys an example if you need some help with that, but try on your own first. I'll show you what it looks like. Firefox checkpoint. It looks like this. Oh, I forgot to copy it. Whoops, I forgot one thing. I have to actually add my code. Again, the code, the example we gave you has no config data, so we'll just paste that config data that I have to copy over again. Uh-oh. And then you'll see it'll populate the, it'll populate right there. All right, try that again. Okay, here we go, yeah. And you can see now it's loaded all of the data from the database and displayed it in this nice little component form. And I have all the code for the way I did my way here on GitHub, but I highly recommend, if possible, please try doing it yourself first. And if you are stuck, then talk to a mentor or look at the code on GitHub. With that in mind, were there any questions about this lesson that people had that I could maybe answer before breakout rooms? All right, then with that, we're going to create breakout rooms. I think we have 3 mentors here. And everyone should be receiving their breakout room invitation now.